This is going to be a quick demonstration of the pre-discharge mode on the Pathfinder BMS. What pre-discharge is good for is if you have a large inverter like this one connected to your system. They all have a big capacitor bank, and when you connect them directly to your system, usually the BMS will detect a short circuit as the inrush current for the capacitors charges up. So what the Pathfinder BMS has built in is a pre-discharge circuit. When you don't have that, you would have to manually connect a resistor across the BMS in order to power on the inverter without triggering the short circuit. When I plug in my inverter to this battery, the BMS is going to shut off because it'll detect a short circuit from the capacitor inrush. When the short circuit fault times out after 30 seconds, you'll see the pre-discharge circuit start. So there it goes, pre-discharge circuit. It only took about 1/10 of a second for the circuit to charge up the inverter's capacitors, and then the main output was able to turn on without a large spike. This saves you from having to do this procedure manually with a resistor, like you have to do with other BMSs that lack the pre-discharge circuit. So now let's demonstrate what can happen if you have a large load on the system. This is a 0.7 ohm load resistor. I'm going to connect this to my system, and then we're going to try the pre-discharge circuit. Alright, now that we can see the pre-discharge indicators and the charge-discharge indicators, let's try this. When I plug in the inverter, the capacitor inrush current is going to trigger the short circuit detection. Now that's normal. That'll happen with most any BMS. The large inrush current from the capacitor is going to read as a short circuit. So if you didn't have a pre-discharge circuit, you would need to manually connect a small load resistor like this in order to pre-charge the capacitors. But the Pathfinder BMS can do it automatically. As soon as the short circuit fault times out, you'll see the pre-discharge circuit become active. There it is. You may have noticed the active light blinked for about 1/10 of a second. That's as long as it took to charge up the capacitors in the inverter. Now I'm going to demonstrate what happens if there's an overload on the system. So if there's a resistive load or something, or possibly a motor or a pump that's connected to the system, that'll overload the pre-discharge circuit. This is a 0.73 ohm load resistor. I'm going to connect that right to the terminals on the back of the inverter. Alright, so we'll do the same demonstration again. And then when the pre-discharge circuit tries to start, we'll see that there's an overload indicated. That means that there's too much load on the system for the pre-discharge circuit to charge it up, and you'll need to remove some of the heavy loads in order to power up the system. Now what we saw is that the active light was very bright for about a full second, and then the overload light came on, and we got a warning that said pre-discharge fail. It's going to try again after the pre-discharge timeout, but it will fail again the same way until we remove the extra loads. It says pre-discharge overloaded, try removing the extra loads. So I'm going to go ahead and do that. I'm going to switch off my extra loads by removing my test resistor. Now when the pre-discharge circuit engages again, the inverter turns on and the system's active. That's it for this demonstration of the Pathfinder BMS pre-discharge function. Thanks for watching, and I'll see you in the next video.